We have already mentioned RF signal sources in the past few slides, especially when we were discussing the core architecture of DAS 2.0. In this section, we'll talk about different types of RF signal sources used for DAS. Signal source is really not part of the DAS, as we have said before, but without signal, DAS will not work. When it comes to DAS, there are two types of signal sources. Repeater-based, we discussed repeaters at the beginning of the course. It basically takes signal from another signal source and then repeats or amplifies it. And then we have radio-based. Radio generates, transmits, and receives signal. There are mainly two types of radio-based signal source used for DAS. Number one is the base station or BTS, which stands for base transceiver station. Transceiver comes from two words, transmits and receives. And then we have a small cell. The biggest difference between base station and a small cell are base station has more output, more power output, bigger in size, and more capacity for handling calls. So in a way, if a small cell is a BMW Mini, BTS is a monster truck. Now let's look at radio-based signal source. At the core of the radio-based signal source is obviously radios. As we discussed earlier, radio transmits and receives signal that makes the cell phones work. Radio is frequency specific. That means only works on frequencies it's built for. They produce RF signal that feeds the antenna, and in our case, this antenna is basically the DAS. This connection is of coaxial cable because, as you will remember, coax carries RF signal. These radios are commonly known as RRH or RRU or remote radio unit. A very essential part of signal source is BBU or baseband unit. BBU has DSP, signal, which stands for digital signal processor. This converts signals between analog and digital signals. BBU is like the orchestrator in a symphony. It controls, synchronizes, and processes all operations needed for the radio, including GPS information, power management, transport module management, which we'll talk about next. Like any other electronics, radios and BBU need electrical power to run. There will be a power module that can take power from the building and feed the radios and other active electronics. For a base station, for example, common parts of a power module are rectifier, which converts building AC power to DC power, alternate current versus direct current, distribution and breaker panels to supply power to different electronics connected to the module, backup batteries to supply power to the signal source when building power is not available. For a small cell, which requires much lower power, the whole power module could be an AC to DC converter with some embedded power distribution capabilities. When you are making calls, signal source needs to be connected to the core network of the wireless service provider so that it can take your voice or data information and send it to the core network. Core network turns around and connects your phone to the person or website you're trying to reach. This connection with the core network is managed by transport module in the signal source. There are multiple different routers in this connection, and fiber is commonly used as transmission media for this link. This assembly of routers and connections is called backhaul or transport. Backhaul because we are hauling data back and forth. Operators' core network uses GPS signal for timing, which basically synchronizes all communication. You may probably know that GPS timing is synced globally. So radios need GPS timing to be in sync with its mothership or basically the core network. In most cases, GPS antennas will be placed on the roof. Sometimes you may find that the wireless service providers just pull the timing information from the backhaul router instead of the GPS. In those cases, GPS antennas will not be needed. In this slide, I will show a combination of real picture of signal source and block diagram style connections to give a better sense of signal source. Signal source in this case is a base transceiver station or BTS. Also, this belongs to one operator. So what you are seeing in the picture just belongs to one operator. So if the DAS is multi-operator or multi-carrier DAS, then there will be other signal sources that will need to be connected to the DAS. Radio unit here is a standalone module. Although it is the main part of the signal source, it's often physically separated from the rest of the signal source. Usually there will be multiple radios, but for the sake of simplicity, I'm just showing one. Radios can usually be rack mounted or mounted on a wall or pole. This whole 19-inch rack in this case is for power plant. We have rectifiers and breakers in the top and several strings of batteries for backup power. BBU is on this 19-inch rack. Radios are connected to BBU by a fiber cable. BBU is also connected to GPS antenna. And then there is a backhaul assembly shown as a block diagram, and it connects the BBU to the core network. Back to the radios again, they are connected to the DAS via coaxial cable and goes through a DAS tray, which we discussed briefly before. This device basically takes the high output power from the radio and reduces it so that it is within the input range of the DAS.